All right, so a common phrase that we use when looking at graphs of polynomial is end behavior. So what you'll find is the higher exponent that you have and the more stuff in the problem you have, you may start to see there's extra squiggles going on in the middle of a graph. What we really ultimately care about is what's going on the left and the right far ends. So what's going on each end of the graph. So there's two ends to every graph. There's the infinity side, which is the right side of the graph, and then there's the negative infinity side, which is the left side. All you need to know is what the degree of the polynomial is and the sign of the leading coefficient. If you know those two things, you can tell, even without looking at the graph, you can identify what's going on with the end behavior, both on the right and the left side. So there's always going to be four cases. Either your exponent is going to be even or it's going to be odd. So your degree is either going to be even or odd. So if it's even and the leading coefficient is positive, so for example, x to the fourth plus x, this has degree 4, so it is an even degree polynomial. That is what the actual graph of it looks like, but even without seeing the graph, if it's a positive even degree, it's going to look something like x squared. So we know that positive x squared kind of looks like a smiley face. So this is also going to kind of look like a smiley face overall. It might have some weird stuff going on in the middle, but the ends are still going to both be pointing up. So we would technically say, well, on the far left side, it's going up, and on the far right side, it's going up. So it points upwards on both ends. The way to present this is such. As x goes to infinity, so that means as we look further and further to the right, and as we look further and further to the left, f of x means the height or the y values. It means as we look on the right side, the y values get higher. That means we end up going up. If we look on the left side, it's still pointing upwards. So the y values still get bigger and bigger and bigger. So a really short way to think of that is ask yourself, on each end, is the arrow pointing up or down? So if I drew arrows on these, they both would be pointing up. So on the right side, it's pointing up. On the left side, it's pointing up. So therefore, that's why we have positive infinity for both. If you have a negative leading coefficient, but still an even degree, it's going to resemble the graph of negative x squared. So negative x squared is kind of like a frowny face. So this may have some extra junk in the middle, but it is overall going to look like a frowny face. This is the actual graph. So even though you have some weird stuff in the middle, you can see it's still frowning overall. So on the right and the left side, you want to tell me, well, it looks like it's going down. On the right side, the arrow is pointing down, which is towards negative infinity. And on the left side, the arrow is also pointing down. So it has the same end behavior on each side of the graph because it's symmetric. So if it's smiling, of course it's going to do the same thing on each end. And if it's frowning, it's still going to do the same thing on each end. So these guys should always be in agreement. So what if you have an odd degree? You're still either going to have a positive leading coefficient or a negative. So if you think of the graph of x cubed, it kind of looks like this, like half up parabola, half down parabola. Looks something like that. It's the same thing. As long as you have positive and it's an odd degree, it's going to look something like that. It may have extra stuff in the middle, but the arrows are still going to be the same. So if you were to actually graph this on Desmos, you would get a graph that looks like that. So it looks a little different than x cubed, but you can see the arrows are still ending the same way. So you're going to begin like normal. You want to tell me what's going on the right side and what's going on the left side. And then we're going to answer those questions. So on the right side, it looks like it's pointing up. So on the right side, on the far right, we have an upwards arrow. That's positive infinity. On the left side, the very far left, it's going down, it's pointing down, and that's towards negative infinity. So notice it's different than these even degree problems, right? We have the same end behavior, and this one has opposite end behaviors. And you're going to find it'll switch if you change it to a negative leading coefficient. The graph of negative x cubed is basically this thing flipped around. So it would be up on the left and down on the right. So that's the graph of negative x cubed. And this is going to look something like that. Here's the actual graph, so it gets a little like kind of weird in the middle, but it still has an up arrow on the left and a down arrow on the right. So again, as we look on the right side, this time we see a downwards arrow, so that's negative infinity. On the left side, we see it has an up arrow, so we see positive infinity. So the answers are just simply reversed. So what was positive is now negative, and what is negative is now positive. So these are your 4 situations. Every problem you get is going to be one of these scenarios, right? It's either even or odd, and it's either positive or negative. So if we try to apply that to the following examples, first thing you want to do is make sure they're in standard form, because sometimes they like to sneak and put maybe like an x to the 6 right here. So I just do a real quick check. 4, 3, 1. Okay, this is in standard. This one's in standard. And this one's in standard. And they want the end behavior, so you're going to set it up. I want to know what's happening as my x values go towards the right and what happens as x values go to the left, or what's going on the right side and what's going on the left side. So you want to start your setup the same. And if this has a negative and it's even, it kind of looks like a frowny face, so it's going to point downwards on both ends. Number 2 is a positive odd degree, so it's going to kind of look like x cubed. So on the right side of x cubed, you would have an upwards arrow. And on the left side, you'd have a downwards arrow. So it goes up on the right and down on the left. And number 3 is actually an x cubed function, and it's the exact same scenario. The number doesn't really matter that's in front. That just makes it kind of stretch or shrink. What does matter is if it's positive or negative. And it's still positive, so the end behavior is going to be the same. So on the right, it's still going to go up, and on the left, it's still going to go down. So I'm going to do one more video, and we're going to go through and kind of answer an array of questions about each type of graph. So they really want you to be able to look at graphs and tell them a lot of information based on that graph.